We want to give examples and explain the difference between vectors and scalars. Okay. Well, a vector quantity, all that means is that it has magnitude. We're going to skip around here. Magnitude and direction. And the difference between a vector and a scalar is a vector has both magnitude and direction, and a scalar has only magnitude. Okay, so if I wanted to give examples of these quantities, a vector quantity, that would be like your velocity. So that is like 10 meters per second east. Okay, in comparison, a scalar quantity would be speed, and that would just be 10 meters per second. Okay, another thing we could compare is distance. That's a scalar quantity. Distance would be 5 meters. But on the other hand, we have a vector quantity that would be displacement, would be like 5 meters north. Okay. So those are just a couple of them. Vector quantity, acceleration, force are vectors, scalar, your time, volume, those are also other examples. Okay. For 35, what we want to do is add and subtract vectors to find a resultant and determine the vectors that make that up. All right. So here we have the same direction. Okay. Since these are in the same direction, we are going to add and keep the direction. So what this is going to look like is, this is going to be 10, and I don't know what the units are, but this is 10 to the right because we had 5 to the right and 5 to the right. So it's going to be even more to the right, okay? Or in this case, you could say east, since I give you this compass over here. What is the magnitude and direction of the resultant vector here? So here we find the difference and we keep the direction of the larger vector. Okay, so I have 5 to the right, 10 to the left. So I'm just going to say 10 minus 5. I have 5 left over. Okay, but 10 is larger. So that means I need to go 5 to the left, or 5 west. And that would be my final answer here. For 102, a parrot flies at a speed of 15 meters per second. It's flying into 2 meter per second headwind, going the opposite direction of its motion. How fast is it flying? Oops, guess you can't see that there, huh? Okay. So for this one, we're talking about speed. And we have a parrot flying at 15 meters per second. Okay, but then it's going into a headwind, which is blowing in the opposite direction. So that's 2 meters per second. So since they're going opposite directions, we subtract. 15 minus 2 is 13 meters per second. And we keep the direction of the larger one. Since 15 is larger, then I know it's 13 meters per second to the right, and this is going to be a little bit short. It's going to be 2 units shorter than the 15 arrow. Okay, but it's going to be to the right. So here we have an airplane flying at 700 kilometers per hour, but this time it has a tailwind, so that means it's blowing from behind. So this is my 700 kilometers per hour, but then I also have 100 kilometers per hour, the same direction, and anytime they're the same, what you're going to do is add them together. So 700 plus 100 equals 800 kilometers per hour, and then we're drawing this just a little bit longer. So for 36, we want to be able to find the net force using a free body diagram. So if I take a look here, it kind of looks here like I only have two forces working to the right. So I have one here at 5 newtons. I have one here at 10 newtons. So I'm going to, since they're in the same direction, add them together, and I get 15 newtons to the right. Here I have 5 newtons to the left, and I have 10 newtons to the right. So I know, since they're in opposite directions, I know I'm going to subtract. So I get 5 newtons, but to the right is larger, so this is also 5 newtons to the right. For this one, I have 5 to the right, 5 to the left. They're going opposite directions, so I can subtract, and I get 0 newtons. And notice I don't put a direction here because it's not going in any direction. All right, it would be either at equilibrium or at rest. And then for the last one, so I have 4 directions. So if I'm going to find the net force, I have to do it all the directions. So the net force in the up and down, so the y direction is going to be 20 minus 20, so that's 0 newtons. And the net force in the x direction is going to be, I have 10 and 15. 15 is larger, so I'm going to say 15 minus 10. So that's 5 newtons. But 15 is the larger one, so I'm going to say to the right.